All right. So hi everybody. Welcome. Welcome to Denver Droids. My name is Dave. I think most of you probably know me, but I see a few faces, so I'll do a quick introduction. My name is Dave Smith. I work here in Denver for Possible Mobile, formerly known as Double Encore. I'm a lead Android developer there. Spend most of my time working on sports apps, broadcasting apps, that kind of good stuff. When I'm not working, I'm usually working on other things. I've written a book called Android Recipes. I didn't bring any with me. I forgot them. So I will bring them next time because I have plenty to give away that I don't want anymore. Thank you. So I will bring those to the next meetup. What's that? Second edition? Third edition. Oh, really? Mm-hmm. Yes, no, it is current. I'm not giving away old books. So, but you know, if you don't manage to get a free copy, check it out. It's from A-Press. Help beef up your skills that way. So, what I decided to talk about this week is RecyclerView. So first of all, let me just ask a question. How many of us in here are developers? Okay, most of us. Cool. Of those developers, how many have used LiftView before? Love it, hate it, maybe somewhere in between. How many of you have heard of RecyclerView? Okay, good. Most hands for all questions. That's good. So RecyclerView was introduced at I/O this last year. They basically build it as a more flexible, more bendy, fancy version of what we've been using ListView for in the past. Okay, so you know, everybody got excited about it, and the question is, well, what do we do with this thing? Okay, so RecyclerView was introduced as part of the new support library. It is not released yet. So if you want to play with this, you have to download the preview SDK that's part of the Android L preview in order to get the new support library components so that you can play with this in your app. Okay. Eventually, when they release it, this will be something that you can use back to V7, which is Android 2.0. Okay. So pretty much anything that most of us are supporting nowadays, you'll be able to use this functionality inside of. So it's not predicated on any new APIs, it's not going to be L only or anything like that. But until Android L officially releases, you can't ship this in code. So even if you're playing around with it, the preview license keeps you from shipping RecyclerView in your app until Android L gets released. Okay. The thing about that, though, is that because it's in preview, it also means that the documentation is not on the web. So if you wanted to even figure out how this thing works, you have to download the L preview documentation. So if you are not familiar with downloading the L preview, just a quick point out that the Android developer site /preview is where you can get all the information about anything having to do with the upcoming Android L and the SDKs associated with it. So there is a section on here for reference. And the reference has this little link that will download a zip file to your machine. This is essentially the zip file of the Java docs that you would find on the developer site. Okay, so you have to download this to your machine, and then you have to manually load up in your browser the index file, and then you can browse through the L preview documentation just like you would on the Android website. But it has all the new pieces in it, like RecyclerView. Okay, so if you want to even get started with this thing, have any idea of how it works, you probably need to at least download that. Because if I just try to hunt for RecyclerView on developer.android.com, it's not going to give me a whole lot. It'll actually give me a couple of articles about what RecyclerView is, because it's been mentioned in many of the announcements associated with it, but no SDK documentation whatsoever. Okay. Once it's released, that will change, but for now, we have to actually pull that stuff down manually.
Or through the SDK.
Well, this piece here you have to download from this link. The SDK manager will not give you the reference docs.
Well, what is this documentation for Android preview SDK?
Let me look. Because it didn't used to be there. Maybe it's there now.
Maybe they just, well, I think I installed this.
So under Android L.
I just wonder if it's not.
You're talking about this piece here?
Yeah, it's not the same.
You know what? It probably is, but this is when this stuff gets downloaded into your SDK package, and this is only accessible as JavaDoc from within the IDE.
Okay.
So this might allow you, while you're trying to mess with the code, to jump into JavaDoc from inside Android Studio or Eclipse. But if you just want to actually pull it up in a browser, that stuff won't work for that. Okay, good question. All right, so as far as just getting started is concerned, you're probably going to want to pull those things on your machine. All right, so since everybody's used list view before, you're probably familiar with this, but just kind of a background for everybody in the room. List view has this really neat feature called view recycling. This is something that's been part of the SDK forever. Android's not the only mobile platform that does this. This is a very common paradigm on mobile devices for managing memory in views of large lists of content. Okay, so the idea here is that list view never creates more views than it actually needs to fill the screen. Right? And as the view scrolls up and views that were being used before go off screen, they get repurposed down to the next section of the list so that we really only have as many views as we need to show our content. And then when we want to bind new data to those views, we just get them back in from what's called a recycler or a recycle bin, or they have different names. But it's really just a mechanism to take unused views and repurpose them somewhere else. Okay? So this is a mechanism we've all used, even if we didn't know it existed, by using list view. Okay? The view recycling portion of this is where the name RecyclerView comes from. It's essentially an adaptation of what we currently have in the SDK as just a simple way to vertically scroll lists, or I guess there's grid view too, which is really just a segmented version of list view. To have multiple columns in there, but effectively we only have a vertical scrolling container of any kind. It's not really very flexible. If we wanted to create a horizontally scrolling list of items, we can't do that with the SDK. Now people have written libraries to do that. That's a different story. Or maybe I wanted to create just maybe some two-dimensional grid of items that I could pan around, and I wanted to be able to use recycling so that I didn't have all 1,000 views or whatever it is attached at that one time. The list view APIs don't really allow you to do that, right? So list view is very rigid and very focused on this one specific task. So that's where RecyclerView comes in. Okay? Many people have asked the question, should we consider RecyclerView as the next list view? Should we dump list view and just use this from this point forward? I'm not sure the answer to that question is yes. There are many ways, and I'll show you an example, how you can use RecyclerView to build a simple vertical scrolling list just like you would have inside of ListView. But even when you do that, it turns out there's a fair number of features ListView has that don't directly map over. Okay? So there are cases where RecyclerView may be a better choice than ListView, even for simple vertical scrolling, but I'm not sure you want to just toss ListView by the wayside and continue using this in every single possible case. Okay? So for instance, the features that are in ListView that you will not find given to you for free in RecyclerView are things like click listeners on items. So if I want to handle tap events from whatever specific item happened in the list. In ListView, I have a nice adapter-based listener to do that. It tells me what item was clicked, what was the position, what was the ID, and I can act on that. Okay, so I'm not actually managing click handling on each individual view. RecyclerView doesn't give you that. Okay, so you have to manage that back in a similar way that you might expect, where I have to interact with each individual view in some sort of a click listener and map all that back. Okay, and I'll show you. I'll have an example of how you would basically do that. It's fairly simple, but it's not for free anymore. Okay, dividers. So generally, a list view has dividing lines that are drawn in between each item. Now, there are a lot of cases where we try to turn those off. So those aren't necessarily always something you want. But if you're expecting them to be there, they're not going to be there in a RecyclerView. They're not drawn by default. I'll show you a way you can add them back, but they're not going to be there necessarily. Default list selection. When I tap on an item in a list view, there's some default highlighting that happens. I don't have to write that in based on whatever platform I'm on. That doesn't exist, right? If I want to create some indication that I've tapped a specific item, I have to write that code into each individual view to change state based on being pressed. Now, sometimes we would do this with list view anyway, and we wouldn't use the list selector at all. But if you were ever using that, you're not going to have that here. Okay. So we start to lose some of this narrow focus on the vertical list option when we start to create something that's supposedly a little bit more flexible and used in different cases. Choice modes, has anybody ever used those before? A couple people. So ListView supports the ability to do single or multi-selection. So I can have a single highlighted item and ask the ListView at any time what position is checked, or have multiple checked items just by setting a choice mode. That functionality is gone. Right? There's nothing like that in RecyclerView. You would have to write it back in. Okay. Header and footer views, the ability to just add a static view at the top or the very bottom of your data set. Again, not part of RecyclerView. And scroll bars even. Scroll bars are not on by default in RecyclerView. You scroll the content, but there's no scrolling indication on the side. Now you can enable it, and actually that one's not too hard to just flip back on. There's a feature to do that, but by default it is shut off. Okay. Yeah, go ahead.
Is there a fast scroll equivalent?
No, there is not. Yeah, no sectioning or any of those that functionality. Those things that are all really focused on that list type content are still going to be specific to list view.
It would be a lot of work to try to make a recycler that's just like has all the features.
Had all the features, absolutely. Yeah. So this is, I mean, if you're using RecyclerView in a vertical case, it's really more for the case where you were using list view before, but you were fighting it so much by turning all this stuff off. Now you have a more simple implementation to start from, and when you see the example that I've written, you might see kind of the common use case of it, from my perspective anyway. But there are a lot of neat things that we now have in RecyclerView as well. Layout managers is something we're going to talk about, which is basically just the ability, there's a couple given to us by the support library for different types of scrolling, but this layout manager is really the true flexibility piece. This is what allows us to create a view that has child elements positioned in any way we want. We can scroll in any direction we want and have control over that whole thing. Okay, Layout Manager does that job. These things are not trivial to write. They're not hard to understand, but actually writing one is probably one of the most frustrating things I've done in a long time. But I do have an example that you can see that works. Touch listeners. So we don't actually have item click handling, but RecyclerView does give us item touch handling, which is a little bit different. If you know the difference between a click listener and a touch listener, you know, a click is a very basic interaction that the system manages the individual touch events for you. A touch listener is basically noticing every down, move, up, whatever, and you'll get that on each individual item. So that may be something that you need and is helpful to you, and theoretically you could from that derive a click listener. It just means you'd have to handle all those events directly, which is not the way that I did it. Yeah.
Can you use, there's like gesture managers or listeners or something, can you use those in conjunction to get the double click and all that good stuff?
Yeah, you could put a gesture detector on that touch listener or something like that, absolutely.
So it would be easy, like if you had some grid that wasn't, uniform, things stacked.
Sure.
Would it be easy to do like a drag and drop type of thing on a RecyclerView, or would that not really?
I'm not sure that easy is the right word, because I mean, generally speaking, in terms of drag-based touch, just like the traditional adapter views, those types of gestures are designed to be controlled by the parent for scrolling. So the idea of would I be using that to do a scroll versus a drag and drop of an item, you'd have to do a little bit of work in there in your layout manager to know the difference. I don't want to say it's not possible, but it would be a little tricky. But when I show you how you would build your own layout manager, you can kind of probably start to see how you might do that, because there is a way. So keep that in mind. One of the big ones that was a very frustrating thing to try and do on the traditional list view, item change animations, right? So if the list is visible and I'm adding a new item to the list, or if I delete an item from the list, having that animate out and the rest of the list, sort of collapse back on the empty space or make space and bring in the new item. That whole animation with traditional list view, I mean, there are videos upon videos done about how to make this happen, because it's a lot of work. It's a lot of code with the traditional APIs. RecyclerView builds that in. So there are default item animation capabilities, and then you can extend that with your own types of animations if you would like. Okay, and that's just given to you essentially for free. There's some caveats to it that I'll show you, but for the most part, it works pretty well. Okay, and then this last one that's on here is really more for those of us who would be building our own layout manager. With traditional list view, we're kind of at the mercy of the framework about when and how items are recycled or reattached, and it's generally happening one at a time. So while it happens very quickly, list view sometimes can stutter on certain devices because it can only recycle one view at a time. So if you happen to be able to scroll fast enough, you can see stuttering as it tries to recycle or recreate a new view. It's hard to do, but it is possible. That could be much, much worse if we were doing, like, say, a 2D grid, where as I pan over, I have 5 or 6 items that I need to add at once. So with RecyclerView, since you control the layout manager if you're building your own, you basically control how many items at any given time get reattached, moved around, or detached. So you can do them in batches. Okay, so if that makes more sense for the implementation, the capability exists inside of RecyclerView. Okay, cool. All right, so the basic list is extremely simple to implement. One of the things that we have with RecyclerView that we didn't have before is there's essentially a default layout manager provided that you can attach to your RecyclerView called the linear layout manager. This allows us to do vertical scrolling like a traditional list view, or horizontal scrolling like most of us have wanted to do for a very long time. Okay, so with the same linear layout manager, by just changing the directional flag, we can create a recycler view that can scroll items this way or this way. Okay, and still get the same view recycling functionality even when we're going in the horizontal scrolling. Okay, so that's one new feature that we just flat out get for free. Okay, but a very basic implementation is really nothing more than, with list view, we would instantiate the list, create the adapter, we'd be done. Okay, now there's basically just one extra step, which is telling RecyclerView the layout manager it should use in conjunction with the adapter. Okay, since most of you have used list view pretty regular already, I'm not going to talk too much about how adapters work and what they're for. I think you guys probably have a pretty good handle on that. RecyclerView uses the same adapter pattern, although the adapters are a little bit different. Okay, so I'll talk about that. Is anybody familiar with the view holder pattern? Okay, not quite as many, but a couple. So the idea behind this is a pattern it's a design pattern that's been around, as long as Android. It's something that was not really baked into the framework, but Google sort of recommended for high performance lists. The idea was that you created this external class that held on to a reference of the view itself as well as all the individual items inside that, all the subviews, if you will, that you would want access to while you're working through the adapter. The idea being that find view by ID is theoretically a slow call to make. So making it all the time as you're binding data can possibly have a performance hit. So they basically just tell you create a view holder instead so that you can get references to all those ahead of time so that you don't have to keep calling find view by ID all the time. It was nothing more than a good practice. Some of us did it, some of us didn't. There are even people who argue that Google was wrong in saying that that is actually slow. Yeah. I don't do it that often either. There have been cases with really, really heavy views where I've seen value, but in the most case, I don't do it either. However, yes, go ahead.
Why wouldn't you just make a custom view and inflate that?
It's essentially the same idea. For the most part, it is the same idea. The only reason maybe you wouldn't is I don't want to put additional logic in it, so maybe I'll just do a holder instead. But functionally, exactly the same thing. And oftentimes, that's why I don't, is because I end up having custom views for items. Because then you can add business logic and other things that can kind of encapsulate that. So that's a very good point. But what they've done inside of RecyclerView is the RecyclerView adapter very much strictly enforces the view holder pattern. Okay, so if you can probably see up at the top there, but the RecyclerView adapter that you instantiate actually has a generic type associated to the view holder you're going to return. Okay, and view holder is a type that's now part of the support library. Okay, so this is something that RecyclerView pretty much requires you to do now, even if you weren't doing it before. And there are some advantages to it once you start getting into building your own layout managers, because in addition to what you would do for just providing references into your subviews and stuff like that, the view holder in RecyclerView also does some work of saving off metadata associated with the view. So it does the work of holding on to whatever the current position is of that view, the current view type, if you're using more than one view type in your adapter, current item ID, and some other values that you might otherwise have to, like you would, in a traditional list view, you would get them back in click listeners and stuff like that because they're managed internally. But now that your views could be all over the place, it turns out that some of this data can actually be pretty helpful. So they stick that in the view holder, and then you're just responsible for subclassing it and then additionally adding on whatever references or additional logic you'd like to include to make your view holder easier to bind data into your view. Okay.
So you do have to extend it?
You do have to extend it. Yeah, it has to extend that RecyclerView view holder. And then the generic requirement has to take a class type that extends view holder.
So that's what I was going to ask. Is the view holder the generic
Yes.
implementation?
Yes, it is.
You have to have a separate view holder for each view, for each list, or whatever it is.
Well, so you'll have one for each item. Is that what you mean?
Yeah.
Every item view is wrapped in a view holder. The same as the pattern would be, when we used it before. So yeah, that is absolutely the same. But it does point out that if you're using multiple view types, like let's say you have a list view that uses a view type for header views and a view type for actual content views or something like that. So you could put in section headers, or there's a number of reasons you would do that. But you cannot provide different view holders for those different item views. So the view holder knows the item view type, and your holder has to support both whatever different types of item views you may provide. Okay, because of the way the generic works in the implementation, right? It can only be of one type. Okay, I suppose you could do a generic base type. I haven't tried that. That might work, but it might get messy too. It's not really necessary. Okay, the other thing to keep in mind about the way this pattern works, has anybody worked with cursor adapters before, or just array adapters? Okay, a couple people. So you'll notice that the pattern here is more similar to a cursor adapter. It's not a get view paradigm with a convert view passed in. It is a create and bind as two separate methods. Okay, so if you've done cursor adapters, it's the same thing. You get a create call when you actually need to instantiate a new item view or a new view holder in this case. You get a bind call when you're given that view and you just need to put the correct data in it for that position. Okay. So it's a paradigm that's existed. Now it's being enforced more across the entire system. Okay. So a new piece that's come in that's specific to RecyclerView is this idea of an item decoration. This has a couple interesting uses. It basically has two primary functions. The idea is you can create an instance of an item decoration, you attach it to your RecyclerView, and it will apply whatever is defined inside of it to each item view. Okay, so there's two primary pieces here. There's item offsets, and then this ability to do custom drawing. Okay, so there's actually two methods. I'm only overriding one of them here. There's an onDraw method and an onDrawOver method. If that allows you to do some custom drawing on top of or underneath your child views inside of your recycler. Okay, so this is a call that really happens globally all the time that allows you to draw whatever you want either on top or underneath the individual child views themselves. Okay, this is the implementation I'm going to use to reintroduce how to add grid or divider lines back into RecyclerView. Okay, I'm basically going to create a decoration that draws horizontal or vertical lines underneath each item all the time. Okay, yeah.
Can you nest multiple, or is it just one?
One per. You know what? I don't remember. I think you might be able to add multiples.
Yeah, I guess you could create a composite pattern if you needed to. But I actually created something similar to doing this.
Yeah.
I mean, it's just like a drawable overlay.
Essentially, yeah. I mean, that's one feature of it. And then the other feature of it is this item offsets that gets put in here. So the item offsets allows you to define for any given position. So you may do it the same for all views, but if you want to do it differently for different positions, should you apply an inset rect to each view? Okay, so it's essentially allowing you to add margins without having to deal with layout params. Which if you've ever tried to do inset margins on a list view with layout params, it works, but it's kind of a pain. This allows you to just sort of do that and not have to worry about defining it on the actual view itself. Okay, so like in this case, we just take the rect that we're given and we can set it with a specific value, and whatever value we set for the left, right, top, and bottom will be inset on the view. Okay, do you have a question? On this?
Yeah, just a little bit.
That's a little hard to read.
On this I can't, but I'm going to show you the actual code in a minute,
Oh, okay.
and that'll be much bigger because I zoomed that in. So yeah, that'll make more sense in a minute. But the idea here is eventually you're given a rect, and any value you put in that rect is essentially subtracted from the bounds as margin. Okay. So I take the same value, I put it on all four, and that makes the view that much smaller than it would have been. Okay. So it kind of gives you that card look, if you will, where a view would otherwise be stretched out to the full width, but you can just kind of get that margin consistent across all of them. Okay. So we'll look at decorations here in a little bit more. Item animators. So this is what I mentioned before about animating changes. So there's an implementation called the default animator, which is, in the examples I have, that's the one I used. I didn't actually create a custom version of this, but they're not terribly difficult to do. Essentially, there is a callback method for all the different types of changes that may occur when you're modifying the data in your adapter. Okay, so if you're adding a new item, there's an animate add method. Animate for a move, which is essentially an item that was there and is still there but is now in a different position. How should we animate that change? and animate remove for an item that used to be in the adapter and now it is not. Okay, how should we animate that removal? The default animator does fade out for removal, then slides things into place, and will fade in new items. Okay, so I don't have examples of custom, but I can show you some examples of people who have done things where that add and remove is like a slide in or a slide out, or like a grow or a shrink, things like that. So really, all you have to do to implement one of these is tell the system what animation you want to provide for each of those different change types, for an add, a remove, or a change. And then those essentially all get queued up inside of these animate, add, remove, change calls. And then the return values are all Booleans. And the idea is if you ever return true from any one of these methods, that tells the framework that on the next run loop it needs to run all those pending animations. So then there's another method, run pending, that lets you run through the animations you just queued up in any order you prefer. Again, the default does add, no, it does remove, change, and then add, I believe is how it does it. And if you wanted to change that in your own implementation, you have the opportunity to run those animations whenever you want.
So this is very material oriented.
In terms of the concept, sure. Yeah, the idea that every change is associated with motion, right? But at the same time, people were trying to do this stuff long before that as well. They just happened to do it with very nasty hacks with pre-draw listeners in order to get the position changes and stuff like that. That's all been baked into RecyclerView. Now you just have some simple callbacks to implement.
What about animations on scrolling and things like that? Like making views overlap. Can you do something like that with it, or is that something that would happen?
What type of an animation are you describing? So you said on scrolling, meaning like animating items that would be added from the recycler?
Yeah, or like the company I work, we have an iPhone app, and it has sort of like cards that slide down, and as they come into the list, they're overlapping each other, and then each one slides down into the middle.
Sure. So
does it have that ability?
Well, it has the ability, absolutely, but whether or not you'd be able to obtain it with just the basic animator APIs, probably not so much. What you're talking about more is now you're starting to talk about getting into a custom layout manager, where the layout manager, which you could do, I mean, the layout manager could just lay out all its children so that they're overlapping, and then as you scroll, the top one or whatever comes to a completely different position or whatever. That flexibility exists in layout manager, but it's not going to be just something that you do with some simple animation callbacks, essentially. So definitely possible, just a little bit more work. Okay, and then we have the custom layout manager, and I will show you some examples of the one that I created, which as layout managers go is actually probably pretty simple, and you'll see exactly how much code it is just to do that. But the basic idea is that a layout manager is a callback driven piece of code that's responsible for telling the recycler view when new child views should be added, where they should go. It actually does the measurement and layout of every single child view when it's necessary. And the framework just simply tells the layout manager when it needs to trigger a new change. So there's an initial callback up at the top there for on layout children. That's essentially the first call into the layout manager that says, this is your initial chance to lay out all the views you need and just get the whole thing started. And then from that point on, this method will only be called again if the data set actually changes. So if notify data set changed and the adapter is triggered and you have a whole bunch of new data, you'll get a new call to on layout. But for the most part, this doesn't get called very often. It's just sort of the initial trigger to say, you got to build everything up. This is your first shot. Okay. Then there are these additional methods for scrolling horizontally and vertically. So when you ask the question about drag and drop, the idea is that the layout manager tells RecyclerView at any point whether it can or can't scroll in a given direction. So, by default, and the way I've got it in mine, these just return true in both directions because I want to be able to pan in both directions at any given point. Okay, I want all those gestures to be handled as scrolling. Theoretically, if you say long pressed on a child view and then for the duration of that gesture you wanted that to be a drag, you would just need to flip those around temporarily to false so that the recycler view doesn't try to take those touch events as a scroll.
Okay. So you could do that, just programmatically just turn those false.
Right, you'd have to track the touch events themselves and then know when that gesture is over so you can tell it's okay to start scrolling again. But RecyclerView will always check with the layout manager during that process to know whether it can scroll or not.
Does the layout manager know about the adapter? didn't see that either.
Not directly. And the idea is that the separation of concerns there is pretty strong. Like especially with the whole view holder concept in between, that basically anything that the layout manager, at least that Google believes, the layout manager should know about the views themselves should be encapsulated in the view holder. It should not have to go talk to the adapter for anything specific. So if you wanted any metadata in addition to things like position view type that's already there, encode it into your view holder, because when views come back from the layout manager, you can get access to the view holders themselves. And in a roundabout way, you could find the adapter, but the idea is not to talk to that. The adapter does the creating and binding of views and associating any metadata in there. You would, in the layout manager, get that information from that point. Yeah. So then the idea is, as the user actually scrolls around, initially you would only lay out however many child views actually fit. And then as you scroll, you need to react to those changes. Okay, now there's a gap on this side. We need to add in more views from the recycler to fill in that space. Okay, and then maybe they scroll over this way. So what ends up happening is we have these additional methods for scrolling horizontally and vertically, and they have a couple jobs. The first is they tell you how far they think you should be scrolling based on the gesture movement. And it's your job to figure out if you can actually scroll that far, because you may have hit a boundary. Like this is the end of the content. And at that point, you would return back how far you actually scrolled. And the framework knows that if there's a difference between what they said and what you said, to start drawing an edge effect because you've hit a boundary. Okay, so all that's sort of built in. But you're responsible for what you return from this method and whether or not you actually shift all the child views by that distance or how far. So it's your responsibility in this method to first move the views. RecyclerView doesn't do that. You have to move them. There are helpers for that to basically just say offset all child views by some distance. So you don't have to go iterate through each one, but you have to tell it exactly how far they should move, if at all. And then based on that change, do I need to start filling in more views? Do I need to add some views or have enough views scrolled off screen that I can throw those away or put them into what's called the recycler? Okay, so inside of pretty much all of these methods, those of you that can see it, one thing you're passed is an instance of something called a recycler. This is really probably the biggest lifter in the entire RecyclerView framework. This is whatever is going to be doing work for you, it's the RecyclerView, or the recycler itself. So the idea is anytime you as a layout manager need a new view, you just ask the recycler for a view for the given adapter position. I need item 0, I need item 1. It will go to the adapter, get the view, get all that stuff, and return it back. It will also do the work of knowing if it needs to create a new view or if it can reuse one that's been stuffed back in it from a previous operation. Okay, so the recycler does all the work of determining where the view comes from and what data gets put in it. You don't have to worry about that in Layout Manager. You just have to worry about when you have views that you don't need anymore, you detach them and hand them to the recycler. And when you need a new view, you always get it from the recycler. And it does the work of determining whether that's a reused view or not. Okay. All right.
Can I ask a question?
Yes, you can.
So what are the units? I noticed they're pinned too, which is strange.
What, because they should be floats?
I'm not saying they should be. I'm just saying I actually prefer in, but
Yeah, they go back and forth on that. Depends on what you're looking at, but pixels.
They are pixels. Okay, well that's well pixels. It makes sense for.
Yeah, I mean any view-based operation that you would ever do in the framework is always in pixels. Yeah, scroll by and stuff like that on view group. That's all pixels.
And this is real pixel, like hardware pixel, not like.
Correct. Right, because the idea is at this point you're dealing with actually how far was a gesture and how should the scrolling track that. So the idea of asset scaling and other resource things, we're beyond that at this point. Yeah. Okay. Good questions. Okay, so now I'm going to actually show you some interesting examples, and then I'll come back to this slide. But just to give you an idea of what's here, I don't have time to go through building an entire layout manager from scratch and showing you how that works. But I have an example of one working that you can look at. And if you want to actually read a walkthrough of how to build these things, I have a series of blog posts that I'm in the middle of right now on my blog. So that's what that first link is. That's my personal blog. And there's a blog in there. Also, if you get Android Weekly, they've been linking to it in Android Weekly. So it'll be in there as well. But that'll give you a better idea in detail of, for each callback, how do you do what you need to do and tie it back to the example that I'm going to show you. Okay. Right now I'm just going to show you the code, show you how it works, and then kind of give you other resources. The code is on GitHub, So it's on my GitHub. It's called RecyclerView Playground. So everything I'm going to show you is straight off of that GitHub example. And then the Android L preview, like I said before, you're going to need the reference guide that I showed you. And when you download the L preview SDK, if you go into the samples directory, there will be some samples under support 7 demos that have to do with RecyclerView as well. Some of the basic stuff showing you linear layout manager. And they actually do show you how to build a custom layout manager, although it's actually just a re-implementation of vertical linear scrolling. So it's not actually anything interesting, but it does show you all the callbacks and how they actually work. Okay.
I'm sorry, I think you said this already. This when it's finally released, general release, it's still going to be support 7, right?
Yes.
Yeah.
Yes, that's correct. That won't change. It's still going to be in the support library. It's still going to be supported back to V7. Now I will show you one thing. It's in the GitHub repo as a note in case you forget it, but I'll show it to you in the code as well. There is sort of an interesting thing that they've done with the L preview. I don't know if it's on purpose or if it's an accident. I've heard both people say, or I've heard it from different people. But the idea is when you start incorporating Android L components into your app, by default, it starts changing the MinSDK version of your project to only run on Android L. So if all you did was essentially incorporate in the RecyclerView as a library and started working in, when you built your app, you wouldn't be able to load it on KitKat or anything else. It would only work on an Android L device. It's basically just because of the way they set up the library project and the way the Gradle build works. It takes the highest value, merges it in, and then it sets that as the MinSDK. Okay, it almost sounds like they did it on purpose so that while it's in preview, you're not shipping code with it, but it's actually not that hard to override either. So essentially, that's all this is. Inside of your manifest, if you start playing around with this stuff, you're going to want to add that tools replace into your manifest. That essentially allows or tells it that it should use the values in your main manifest and not merge anything in from other projects. So you can actually set the MinSDK to something useful, and you can try this stuff on KitKat, Jelly Bean, whatever you want. The emulator that I have is 4.1, just to show you that it actually works. Okay. All right, so let me show you a couple examples here.
You said the emulator that you're going to show us on is 4.1.
Uh-huh.
I thought you were saying you couldn't release an app with any of this code.
That's correct. The Preview SDK license precludes you from shipping it to Google Play.
Okay.
Functionally, I could do it, and if Google found out about it, they'd be mad.
Yeah.
But yeah, no, it's not a functional issue, it's a licensing issue.
Gotcha.
Okay, so I'll show you the example first, and then we'll walk through some of the code, just so that you have a feel. If you're downloading the code and you're playing with it later, you can kind of see what's going on here. So what I've got here is just a couple of examples, all using RecyclerView. So I've got a vertical list, a horizontal list, and then I've got a couple implementations of this two-way list, which is this two-dimensional grid that I've been telling you about that's a custom layout manager that I've written. Okay, so we'll start with the vertical list. So, I mean, you look at it the way it is, and it looks pretty similar to a list view, right? You know, everything's scrolling. I've got my dividers in here. I've got some neat little padding in here, and that's maybe not something you would typically see in list view, but it works just like a list view. I can scroll it up, scroll it down. I can click on items, and they highlight, and I've got a little toast that shows up in there. So this is all functionality that's pretty standard, but I did it all with RecyclerView, and not all of this was given to me for free. Okay, I had to add some pieces to make some of this work. All right. One of the other things that we get with this are these item change animations. So if I want to add a new item to my adapter, inherently, because of the way RecyclerView is set up, there's a default animator that will do that in an animated way for me. Okay, so if I add a new item to the adapter, and you'll see the code that does that in a minute, it will animate that change into place, right? It will slide out of the way and fade it in. Okay, same thing if I...
Not the default.
That is the default. That is what you get without having to write any item animations. And then if I want to remove an item, same sort of thing. It fades out and everything moves in place. Okay, so I don't have to write any code to do that. Okay, that's just handled for me in the vertical and horizontal implementations. Okay, so that's kind of cool. Then I have a horizontal list that's effectively the same thing. But now I've got recycling functionality horizontally, and those of you who have been developing on Android for any length of time should be cheering inside right now. Because I've used many third-party libraries to do this. I've even tried to write my own at times, and they all suck.
Why wouldn't you just use a grid view with a single row?
Grid view wouldn't go horizontally.
No.
Nope. Vertical only.
I've been looking for one too. I haven't found a good one.
Yeah.
I said a quiet game.
Yeah, no, I mean, as far as what you're seeing statically, you could, but grid view is still vertical scrolling only. All the existing framework widgets are. There's no horizontal scrolling built into these. The only one that does is gallery, which is kind of a weird, different beast. But gallery does allow you to do horizontal scrolling, but it has this idea of force snapping selections to the center and some other things that you may not necessarily want. Plus, it's deprecated. You're not really supposed to use it anymore. So, and similarly, I get the same animation. So, if I want to add an item, it'll bring that in there. If I want to remove an item, it'll animate that out. Okay, so all those changes again. Now notice here, I don't have any grid lines. I could add them, but I would have to add them in the same way that I did in the other one. It's just to show you that they aren't actually there by default. Okay. And then I've got this. Oh, sorry.
I'm sorry. My brain's thinking because I actually know a use case for this. But if you wanted to have both horizontal and vertical, let's say you had another grid, another grid, it would still let you do the horizontal scrolling.
Like that?
Oh, you already.
Nice segue.
Yeah, thanks for that. So then the next implementation that I was going to show you is the custom layout manager. So those are the only two that I just showed you. Those are the only two given to you in the support library, vertical and horizontal linear. But if you want to write your own layout manager, you can stick things wherever you want. Okay, and so the implementation I wrote is a 2D grid, right? So these elements are laid out left to right in a grid, right? So this first, I have a couple implementations of this, and one I'm actually still working on. It's not quite right. A couple implementations is fixed and static. The only difference is the fixed defines the rows or the number of columns to always be the same. So this one will always have 10 columns, and it'll just lay out as many child views as necessary. The static one actually defines the number of columns based on how much data there is to try and make it as square as possible. So as your data set changes, the number of columns will actually change. Okay, so that's the primary difference. Other than that, they function exactly the same way. But it's the same basic idea where now I can scroll and pan in two completely different directions. And the same way that I did before, I've added in grid lines in both directions, so there's an actual grid in between the items. See, that's not necessary. In fact, I think I only did it on this one. If I show you a static one, it doesn't have those grid lines.
Are you drawing those grid lines per item or across the whole?
It's across the whole view, and I'll show you how that works. That's done with the decorator. So I've got a couple features in here that I secretly showed you just a moment ago where you can change the size of the grid so you can see how it reacts to different adapter data set changes. Now notice that in these nothing animates. And that's another difference between the functionality. There's this functionality that allows you to add or remove items either one at a time or in batches, and that will trigger an animation. But the traditional old school notify dataset change that just says the adapter dataset is now different, that does not trigger an animation. That essentially allows you to just do a new layout with the new set. Okay, so when I'm doing these, changing the actual grid size from like 5 items to 500, that's just relaying everything out. It's only when I do the add remove that I'm triggering that animation piece. Okay, but it's got all the pieces you'd expect inside of a layout. I can use smooth scrolling to animate to a specific position, or all those things that you would typically have in list view. I had to write those in because they weren't there by default, but RecyclerView does give you the ability to do that. Okay, so I'm going to show you how each of these pieces actually work.
I have a question.
Yes, go ahead.
Are your animations static? Just based on lines or just like something basic? Could you animate your recycle animation or your arrows there to turn, or would that be something else that would call that?
Well, I guess the answer to the question might vary for different pieces of it. So, I mean, the question of could I animate these individual items? Sure. I mean, that's just adding an animation to this child view. so that's no different than if I wanted to animate any view for any reason. Animating changes, like for instance, I think the other thing you asked is, could I animate when these views get recycled? So like, I guess that would depend on when to determine a matter of why. So I mean, for instance, the way this is designed and the way most recycler views are designed, views are recycled when they're no longer visible. So like right now, roughly, is when all the views in that top left corner just got recycled. So animating them wouldn't really provide any value because they're not visible. Now, I have full control. I could recycle views before they're no longer visible. And I don't have to add new views just because there's space for them. That you have full control over when you scroll and how you add views. So if you wanted to do that, you could. As part of determining that you need to detach a view, you could run an animation first, and then at the end of the animation, detach the view. So that functionality, you'd have to put it in, but you could certainly do that. And when you see in the code where I do the view detach, you could just sort of substitute that for running an animation with a listener and doing the detach at the end. So functionally you could, although in most cases I don't know why you would, because you wouldn't be able to see it anyway. Although, I suppose there's an argument for animating views coming on screen, like Google Plus used to do, where it would animate cards in. In that case, not necessarily views being recycled, but views that are being added, you could do it that way. So that, yeah, absolutely, that's a possibility. Okay. So let me show you the code to actually make this work. Now notice also that I'm getting the edge effects. So you'll see how I do that, but the framework does all that for me because I'm telling it when I am and I'm not allowed to actually scroll the content based on that gesture. So when I'm dragging, my layout manager is telling RecyclerView, nope, we're at the edge. And it says, oh, okay, well then I'll draw the edge effect. So you don't have to do all that. Okay. All right, so we'll start at the basic and work our way up. So the way I've structured this example is I basically have the base implementation here where it creates the recycler view, sets the layout manager, sets the decorator, and the adapter, and it just does all that stuff the same every single time. The only thing I change in each one of those options is what's the layout manager, what's the decorator, and all that stuff. Okay, so this code is the same regardless, and it's pretty straightforward, right? I have an instance of a recycler view that's in my layout. I can pull up my layout. That's really all it is, right? I just have this in my XML. It gets inflated. I find view by ID. Nothing fancy there. Set the layout manager. Add item decoration. So this is what I was checking for. Add means you can put in more than one. So if you wanted to have multiple decorators that all got triggered all the time, you could do that. And then an instance of an adapter. And my adapter is just providing all of those simple views. Now I am going to look at the adapter so you can get an idea of that here in just a minute. So I've just created a simple implementation of the recycler view adapter. Apparently I set a breakpoint for some reason. Okay, so the adapter has to extend the recycler view adapter, not the list adapter that you typically use with list view. And that is typed to whatever your view holder is going to be. Okay, so you have to create a view holder of some type that's going to house your view and have all your logic in it. And you have to tell, using generics, what that type is going to be when you instantiate this. Okay. So the business pieces of this are simply create view holder, bind view holder. So create means I have to actually create a new item view. So what you would typically find in a get view where you inflate that item layout and but you're not actually having to necessarily find any specific pieces here. And then you instantiate a view holder that wraps your item view. Okay, so my view holder implementation is down here. Just extends RecyclerView view holder and does the work of finding all those references so that we've only done that once. Okay. Now notice another thing that I'm doing in here. I'm also letting the view holder implement click listener. Okay. This is because I don't get on item clicks for free in RecyclerView anymore, like I did with ListView. So the way that I implemented this, and there's a couple ways you could do this, is that each view holder becomes the click listener for its item view. And then when I tap on the item view, I can bubble those item clicks up to the adapter. So they essentially all get funneled up to the adapter, so there's still one common place. I'm not dealing with click listeners all over the place. But that gets funneled up through the item holder up to there. And then I have a custom interface, which is really just, well, it's actually not a custom interface. I'm using the old school adapter view item click listener. I trigger that manually instead of the way that list view would have done that for me. Okay. So essentially there's a, where did I put it? Here it is. That on item click, that's get triggered from each one of the view click listeners. And then I translate that back into what I would have seen with the old school adapter view, which is essentially the item view, the position, and the ID. All that data is in the view holder. So I can sort of recreate that if I want, or do it a different way. I just did it this way to provide one instance. So that's, I have to manage how click handling is dealt with in my item views myself, in whatever way you want. Okay. Questions on this so far? All right. So the other thing here is how I made those changes. So, you know, the simple changing the item count is just where I would modify the data that's attached to my adapter. You know, here's a new data set. I have 50 items now instead of 5, or whatever the case is. Trigger the old school notify data set change. Fine. That still works. That's when I get a new layout triggered with completely new data. No animations, just the same way it used to work. Okay. If I want to do an animation of some kind, then inside of my adapter, when I make the changes to the data set, I have to use one of these notify methods that's part of the RecyclerView adapter. So there's notify inserted, removed, changed, and there's one of these for ranges too. So if I want to say I added 10 items and here's the positions where they were added, then I can do that as well. These tell the RecyclerView that it should trigger the animator to make those changes instead of just completely doing a new layout. Okay. So it's actually important if you want to use animations in RecyclerView, you have to modify how your adapter behaves just a little bit. Okay. Okay. So we'll look at the specific pieces here. So the vertical and horizontal are pretty simple. I'll just bring all these up. So the vertical implementation is just a linear layout manager, which is given to us by the framework. And I simply tell that manager which direction to go. And I forgot what that Boolean flag is for. Let's find out.
Recycler.
Oh, reverse layout. Okay. So if this is set to true, that just essentially says that it's going to lay out position 0 at the end of the list versus the beginning. Okay. So those features are in there. Whether or not I want to add an item decoration, I'll show you how that decoration looks in a minute. So in this case, I'm adding a decorator to draw those grid lines, or those divider lines, as well as generate those insets that were on all the views. So those margins that you saw were created by the decorator. Okay. And then again, I just tell linear layout vertical or horizontal. Same thing with horizontal. Looks very similar. I just have to change the direction. Okay. So to get the vertical and horizontal stuff, hardly any code, right? That stuff's just baked into the framework. And I'm using a slightly different decorator in this case. So let me show you what those decorators look like. We'll do this one. Okay, so the item decoration, just extend that implementation there. And there are a couple of callbacks, as I mentioned. There's onDraw, which I'm not using, and onDrawOver. These are called all the time, but they're not called for a specific position. The idea is this is called with the canvas of the recycler view, and you can draw whatever you want. It either gets drawn underneath or on top of the child views, depending on which one you override. Okay, so this just gives you a raw canvas, and you can use raw draw calls just like you would in a custom view to draw lines, shape, bitmap, whatever. You know, drawables, anything like that.
Every pass through the main thread.
Every time the view redraws, essentially. So anytime onDraw is called in the recycle view, it's going to trigger any decorators, you know, at the appropriate time around its own drawing. So anytime the view invalidates, essentially. Okay. So in our implementation, I just chose onDrawOver. It doesn't really matter because I'm drawing things in between, but decided to put those things over the child views, and we just triggered this method. So basically, this is a global call. It's not per view. So I'm not getting called like for each position, and I can say, well, for the current position, draw underneath or something like that. Just for whatever the current state of the view is, look at all the child views that are currently attached, figure out where the bottom of each one was, and draw a line right underneath it. Okay, that's all we're doing. And that's how I get those grid lines back in each one. Now notice what I'm drawing. I'm actually using a drawable. I'm not just drawing a line. I'm using a drawable that I retrieve from the current theme that is essentially whatever the current list divider is. So this would be the same drawable that would have been drawn for the current list view. Okay, so whatever is set as the list view divider in the theme, I'm just pulling that out. Okay. So that's how I get the lines. And then the offsets piece, we have this get item offsets method that gives us a rect. And says essentially if we want to provide for a specific position, so you can do different things for different views, if we want to generate any sort of an inset for that specific position, we just set the left, right, top, and bottom value of that rect to what the inset should be. So I have just a static value that I think I actually pull out of a dimension resource. Where do I get that from? Oh yeah, there it is. There's the dimension. I just pulled that out of a dimension resource and apply that same one to each individual side. Okay. Now one thing you could do here, what you'll notice in my list, because I was lazy, is that if I go back to something like vertical, notice that the top margin is actually quite a bit smaller than the one in between, because that's actually two margins sandwiched together. So if you didn't have dividers but you wanted everything to be even, you might check for position 0 or for the last position and change the top or bottom margins so that everything's uniform. You know, something like that. One use case of the position anyway. Okay. So those are sort of the two functions you can get out of a decorator. Insets and drawing, custom drawing. And I've got a couple of them in here. This divider decoration is the one I used for vertical. Stop it. There's an inset decoration, which is just the offsets. So that's the one I used to do margins on all the views that didn't have grid lines. And then I have another one for the grid dividers, which is essentially the same thing, but it draws horizontal and vertical lines wherever necessary to make the grid. Okay, so same functionality, just expand it out a little bit so you can inspect that code if you're curious. Yeah?
So can you show me the running app again?
I can. Which one do you want to see?
So those are those rounded corners? So are those?
Yes, they are.
Where's that coming in?
Oh, sure. I can show you real quick. It's not relevant, but I can show you. It's a drawable.
It's just okay.
I just have a background drawable that's using a rounded shape. So this is the background of all the child views. Every child view uses this back as a background, which is that gray rounded rectangle that turns red when it's pressed. Yeah. So that's all we're doing. It's the rounding of it is nothing to do with the decorator. That's just the shape we're using. Okay. So like I said, I don't have an example of a non-default animator. I can show you where to look for examples, here if anybody's curious. The last thing that I have to show you is, let me make some room for it. Big layout manager. Oh, that's the wrong one. I need this. Okay. So implementing your own layout manager. Again, not a very difficult thing to understand how it works. Total pain in the ass to make it work. I will tell you that right now.
How long did you spend on this class?
Weeks.
Seriously?
Weeks. Now I added a lot of stuff to it, like getting it to actually lay out and recycle with basic scrolling. That didn't take more than a few hours. But then, like actually getting it to work right, so that you could fling it and it wouldn't freak out and stuff like that. All those edge cases, yeah, that took a long time.
Was part of that because of just the documentation was sparse, or?
Well, yeah, I guess lack of examples to some degree, but part of it is no. It's just when you start getting into some of this, there's a lot of edge cases involved. When you get the basic piece working with scrolling, and then you fling it really fast, and you realize that there's a really large DX you didn't account for, and it stops way over here. And so there ends up being all these cases you have to start testing and revising your code. So you get a little bit of iteration issues going on in there.
Dave's a pioneer. It takes time.
Yeah, that's right. It won't take you very long because I did all the hard work. No, I'm kidding.
So you're gonna release this.
This is all on GitHub. So, okay. So I won't go through all the code here because it's a lot of code. But how much code is it? 600 lines of code. But I'll just get the basic idea. So the idea here is this thing gets attached to RecyclerView. So the first time that RecyclerView needs to render or lay out all the child views necessary, it's going to pull up in onLayoutChildren. So you're going to get this guy first. Okay, this is sort of your first entry point in. You'll also get this guy if the adapter is ever swapped out or if the adapter data set is just manually changed with a notify. Okay, you'll get this again. So this is sort of the basic or the initial implementation of what you might want to go through. Now, there's a couple things that I do in here to simplify my life. You know, as much code as this was, it could have been much worse if I made it a little bit more flexible. I made some assumptions such that, I go back here, all of these views, all the child views, are always going to be the same size. You know, I'm not allowing them to actually wrap whatever their content would be and be maybe a little taller or wider. The layout engine that I have in here probably would accommodate that, but a bunch of the math I'm doing for where the boundaries are and stuff would totally break. So there's some assumptions in there where I basically just take whatever the first view is from the adapter and I quickly measure it so that I can figure out what the width and height of all my child views will be. And then from there, I can just sort of use that metric throughout the rest of this thing. So if you need to be a little bit more dynamic, you'd have to change like the assumption that I have in here. And I tried to be as explicit as I could with that when you're reading through the code. So in order to measure a view, it has to actually be attached to something. So I actually have to get this view, attach it to the parent view simply so that I can measure it. But I don't actually want that view to be there. I don't need that there at this moment. So I'm actually going to detach it and throw that back to the recycler. So what you'll see when you're working with a layout manager is there are a number of methods called like detach and scrap, remove and recycle, all these sorts of things. Anytime you would need to add a view or remove it, you would want to use one of those methods. So that's not just being detached from the parent, but it's being dropped into the recycle bin. Okay, so you'll see that anytime I don't need a view anymore, I'll be throwing it into the scrap heap. The recycler has this concept of a scrap heap and a recycle pool. If you want to know the difference, read the blog post because it takes too long to explain. But there is a difference. Okay, then just getting some basic ideas. You know, I mentioned that I may get this called on a first layout when I have no children, or I may get this called if I'm just changing the adapter data set, and I may want to behave differently. So one of the things that this code does that, again, was one of those extra features I probably didn't need to add, is that if you change the data set, it tries to relay out so that the same position value is still in the top left corner. It doesn't just reset the whole thing. So when it gets a layout change from an adapter data set, it goes through and does some extra work to figure out what the current top position is and where it's scrolled to so that we can kind of relay out to the same offset. Okay, so that's all we're doing in here. The most interesting work in here happens inside of this fill method. This is a helper method. This is not part of it. This is something I wrote just because what we essentially do is every time you scroll or need to do a new layout, you basically just have to fill in the gaps with new views. So I just created this method called fill that does that work. So we'll see that method here in just a minute. I'm going to show you some other things before I do that. So in addition to that, we're responsible for reacting to scroll changes. So as the view scrolls horizontally or vertically, we have to do the work of moving everything around. So first we have to tell the view whether or not it can do that. So if you're only scrolling in the vertical direction, you return false from this and you never have to deal with horizontal swipes, right? You only get DY stuff. So there's one for horizontal and one for vertical. I think vertical's down here. So in my case, I want to be able to scroll in both directions. Notice what I'm not doing. I'm not using this method to do bounds checking. I'm not saying that when I hit a boundary, this returns false. That doesn't quite work the way you think you would want it to. Instead, that's what the actual scroll methods are for. So inside of the scroll methods for horizontal and vertical is where you do all the work. So you're given the distance that the framework thinks you should travel based on the gesture. So as the finger's dragging, you'll get this called a lot. And it's just an incremental, this is how far you should probably move. And then it's up to you to determine based on whether or not you've hit a boundary, you know, whether you're all the way at the left of your content, right, top or bottom, you know, what should you do? So basically, this method just goes through and determines where, if it can scroll in that current direction. That's what all this stuff is for. If we've reached a boundary, what is the actual distance we can scroll? You know, maybe we're close to the boundary, but we just can't scroll as far as they want us to. So then we can minimize down how far we actually travel, and that's all we're doing in here. So we have to do all that math. You end up doing a lot of math in these things. And then we determine this delta is effectively how far are the views actually going to scroll, and it might be 0. Okay. Then it's our responsibility to move the child view. So this offset children method is simply a helper that goes through and shifts all the child views for you, but it's your responsibility to tell the framework when that happens. It's not like you just return back the distance and it does all the work. You do that yourself. Okay. And then in the same pass, because I've now moved all my views, I have to decide for this increment, do I have to recycle old views or add in new views? So I end up calling that fill method again all the time. Okay. It's interesting, if you actually go look through the source code of ListView, you'll see something very similar to this. It's just a little bit more simplified because it's only in one direction. This idea of scroll fill, scroll fill, scroll fill is very common.
So DX is how far you...
It's the current increment you need to address in the scrolling gesture. And this will happen, like as they scroll their finger, you'll get this called all the time. And then effectively, it's your responsibility to return how far you traveled. How far did you actually move? And then in the source code of RecyclerView, it takes the DX, subtracts it from this, and if that value is not the same, then it says, oh, we've reached a boundary, and it starts drawing the edge effect for you. So if you actually return the wrong value here, it will start drawing the edge glow while you're still scrolling. That was one of the bugs I had to fix. So it's very important that this actually does line up with when you actually hit a boundary. Okay. All right. Questions so far? Yes?
When are you going to write a Pinterest-style picture one?
I've never used Pinterest, so I don't know what that looks like.
Have you ever seen the Moto X camera roll? I don't know if they still have one.
Yes. Yes, I have.
I need one of those.
Okay. Maybe by NDEFCON, we'll see. Yeah, I probably will add a couple more to this, but I don't know what they're going to be. And I got about halfway through this one before I thought, do I really want to do this? Should I do something easier? This seemed like it would be straightforward, but
The world thanks you.
yes, well, we'll see if anybody actually uses it. But okay, so same thing in the other direction, just with different bounds. So it all funnels back to this fill. Right? This is the idea that based on anything, whether it's an initial layout change or a scroll, I have to check all the time, what's my new status? Do I need to add new views or do any recycling stuff? Okay. That's essentially what this method does. Again, this method is pretty heavyweight, so I'm just going to go over the top level pieces of what's going on in here. Now, again, if you look at something like a linear layout, this is much simpler than my version. My version, I did it this way just because one of the difficulties is that because you're recycling views all the time, your view indices don't actually match your view positions, right? Like the index of all the child views is essentially 0 to however many views you have. And I could be showing items 100 through 105 or something like that. So those aren't exactly the same. But in a linear list, they have some correlation. And you can see that the layout managers actually rely on that. The idea that new items are always at the beginning of the list or the end of the list, so they're always item 0 or item get child count, essentially every single time. With a grid, I'm laying out these children in this sort of left to right fashion, and I'm only laying out a portion of it. So as I scroll, if I start recycling views all over the place, then I lose the fact that item 0 to child count has some consistent value to it. I mean, item 0 could be in the middle, and the other one could be over here, and God knows what could happen. So one of the reasons that I did it this way, you'll notice that what I'm doing is I actually detach all the views every time, and I reattach them in the right order, so that no matter whether I recycled views or not, 0 is always in the top corner, and they always lay out this direction. Okay. So there may be less work involved depending on what you're doing, is all I'm saying. So essentially all we do here, the first step anytime we're going to do a fill is we take stock of what we have. Okay, so I simply just go through all the child views. I first check based on what type of a fill it is, whether or not I'm going to be shifting one way or the other with new views. But I just take stock of all the child views in their current positions. So I just basically cache them off, so that later on, when I need to go back and get them for their adapter position, I can just retrieve them back quickly. Now, notice that there's this idea of a detach. The RecyclerView actually helps me with this because I can do what's called a detach of a view, which is different from removing it. Removing a view actually removes it completely from that parent's index, and the idea is at that point it would not be used anymore. It'd be put in the recycler or something like that. But RecyclerView gives this concept of a lightweight detach to you that allows you to temporarily remove the view as long as you re-add it back in the same loop. And this allows us to reorder views like I want to without necessarily being too heavyweight in removing views and getting them back from the recycler just because I want to do this. I can reorder the views I want as long as I still need them. Okay, so essentially I just take all the views, figure out what they are, detach them all. Okay. Then in the next step, I essentially go through and do the actual layout. So from item 0 to however many child views I've determined I can fit on screen, which I determined, again, by cheating, by figuring out that width and height and determining, based on the size of the display, how many columns and rows can I fit. And it just goes through, figures out what the actual position should be for each of those elements. Because since it's just a window, you know, I've maybe got 0 and 1, but then 2, 3, 4 are over here, and the next one I actually need is 10. So I've got a little algorithm to figure out what those actually are. But then it simply goes through for all the views it can see and determines, did I already have that view? Do I just need to reattach it? Or do I need to get a new one? So if I don't have this view already, I get it from the recycler. Anytime I need a new view, I get it from the recycler. I don't care. The recycler could give me a reused view. It could be a newly created one. I don't care. I need the one for this position. And then I need to attach it to the layout. Now, just like if you were building a custom view group, for those of you who have ever done any of that, you're responsible for measuring and laying out all your child views. So as part of the attach, I have to tell it to do a measure pass and do a layout pass. Okay, and I do that for every view that's new to me. The ones that I've already had, they're already measured and laid out. I'm just basically reordering their indices. I don't actually visibly want to remove that view. I just want to change its index. So I'm just attaching and reattaching it. I don't need to lay it out again. Okay. So in that case, those views just get reattached, and I remove that from that collection that I have. Okay. So this is the part that actually takes the views and puts all the ones that I need in the layout, whether they were new from the recycler or they were already there before from a previous scroll or something like that. Then the last step is I may have detached a bunch of views that I actually don't need because they've been scrolled off screen and they're not going to come back. Okay, so anything that's left over in that cache I created at the beginning, they all get relegated to the recycler. They've already been detached. I just have to force them into the recycler before I return from this method. Okay. And then I just do this over and over and over again. This method gets called every time you scroll a little or relay out or anything. This is where all the business happens. Okay.
So detach and attach are really pretty lightweight.
Yes, extremely so. They don't move, like the layout bounds of the view and all that stuff stay the same. So like when I detach position 0 and reattach it, it still knows that it's at this XY coordinate, it's this width, all that stuff. So I don't have to measure and lay it out again, which I would if I threw it to the recycler and brought it back because I would have no idea what state it's in.
Precisely what do they do?
What do?
Attach and detach.
I think they just remove it from the array. Because every view group has an array of children. I think it just removes it. It allows you to re-add it at a new index, but it doesn't actually change any properties of the view. Yeah, so that's why I'm not actually relaying those out, because I want them to physically be in the same space. I just want them to have a different index so that my index pattern of 0 is always up here and so on is always preserved. So that's what's going on there. Okay. Questions on that?
Can you quickly just go back to the scroll?
Oh, the method or the
method, yeah.
Scroll horizontally or vertically? Doesn't matter. Uh-huh.
So dx comes in as that can be positive or negative, right?
Correct, based on the direction.
So if you go down and I was just a little confused. So delta is minus dx.
Right. So this is simply an idea that this is just the way the framework works. Is the idea that the sign value of the dx tells you the direction that scrolling should occur, but when and this is true even when you're doing scrolling with any other view, you have this problem all the time. Whenever you want to apply the scroll directly to the view, meaning the actual pixel shift, it's almost always in the opposite sign. Because to visually see the pixel scroll one way, you have to actually tell the travel to be the opposite direction. Or the scroll offset to be the opposite sign.
What got me confused was you say in that one case, delta equals minus dx, and then you return minus delta.
Right, because again, when the recycler view does the math about the actual distance traveled, it's going to compare it to the original dx. So since here delta was negative of dx, if I just returned delta, it would take dx minus negative dx, and it would never work out. So that I just have to flip that back around when I return it so that I get the right value. Well, I can show you later what happens if I don't. That's where you get that case where I can still scroll, but the framework thinks I've hit a boundary. And so it just shows me the edge glow full on all the time, even when I'm scrolling. So, yeah, good question, though. So, yeah, but I didn't kind of go over that in detail, but we are checking to see whether we're scrolling left or right so we know which boundary to check based on that sign.
I actually missed that. I was looking mainly just focusing in on the delta.
Right.
XDX.
Right. So, and that way we know whether we're checking the right side or the left side and stuff like that. So we do check that sign for a couple different things.
I got a question with that.
Yeah.
So if you go back to your app there, go back to where you're showing it singularly. You just had
The vertical?
Yeah, your vertical.
Uh-huh.
No, maybe with the horizontal.
Sure.
On one of those, your horizontal, the decorative border is already there. It's drawn all the way down.
Oh, I think I know what you're talking about. You were talking about what this one looked like initially.
Yeah.
This one.
That there. So how does that work with your border if your decoration's already drawn and blocked all the way over and all the way down?
So you're talking about how come it scrolls with it while I do this? Is that what you're saying?
No, why are the lines already there?
The line. So
yeah.
So how do you do your border then if because you're really only seeing those top three?
Sure. So that goes back to the idea that I described before when I was talking about the decorations. The idea that those item offsets that we defined for the actual insets. So that's the reason that the views aren't touching those grid lines right now. The grid lines are the actual boundaries of the views themselves. The insets tell it to shrink in a little bit. But the drawing doesn't happen per position. The drawing happens globally for the whole view. So the way I've written the code, it essentially figures out where all the child view intervals would be, and it just draws a line there. So I mean, if you look at this code, it's just drawing across the entire view canvas, those at every interval.
Yeah.
So what I could do, and what I did do, and it looks really weird, is similar to what I did with the vertical list, where it simply says for every child view, draw a line underneath. So that way, when there weren't any views down there, it wouldn't have any extra lines down at the bottom. The problem that happens is then as you scroll, and maybe a view does come into visibility, like for instance on this row. I'll go to the medium one. This bottom row doesn't always have a view in it.
Yeah.
It only has a view here. And since this is being done based on the current set of child views, right now you wouldn't see any of these lines in the bottom set of the grid. But as soon as I get a child view here, all of a sudden a line draws all the way across.
Yeah.
So it's in order to make it more consistent, I simply draw them at every place that an interval would be based on the width and height, because they're static in this case, so that they'll always be there no matter what happens as I scroll. Otherwise, you get that behavior where they show up and disappear based on what's on screen.
Yeah.
So, and I can do that because this canvas is the global canvas for the entire recycler view. I can draw anything I want anywhere I want, and so that's what I'm doing. I'm just drawing that drawable at those intervals, horizontal and vertical. Good question. Okay. Any other questions? Yes.
Kind of just brainstorming, but I wonder if it would be easier to have an on-draw item and take into account the dimensions of your offset, the dimensions of your decorator, so that you could draw that border that you talked about on a per item basis, rather than assuming a full grid would be present. And that way you could deal with these irregular grids.
Mm-hmm. You're saying you wish that was in the framework, or that's something we could have done here?
I wonder if that would have accounted for that better.
Yeah, well, and actually we could, and that's what I was saying. Is I actually did have that in there to some degree. It would only draw the grid lines associated with the child views that were currently attached, but it still drew them full width. So maybe that's the difference. So that in that implementation, go back here.
What I mean to say is, instead of where you return the dimensions of your margin, account for the width that you want the line to be. And that way you can always draw it inside of the child view itself, rather than going full screen width.
Oh, having the actually relegating that drawing to the child views themselves rather than using the decorator.
I don't think of the drawing as being inside of the child view, but drawing on the child view's canvas area.
Sure, which without actually doing it in the view itself is something I can't do. This canvas is the RecyclerView's canvas. To have the individual bounded canvases of the individual child views, I'd have to do that drawing in the item view, which I could do. I absolutely could do that. And then use the insets so that it's not overlapping it. So yeah, that's one option for sure. And then it would only ever be with every child view. I mean, I could do something similar here too. I just have to make sure that I only draw the drawable as far as the child view goes, which right now I draw it all the way across, so that what ended up happening is that right now, in this case, this line didn't exist, and then as soon as I scrolled over, it popped into place. But I could have just as easily said, well, only draw it to the point that matters, and then it would kind of fit the grid. You could do that too.
Excuse me. What is the nature of that drawable?
What is the nature of that drawable?
What type of drawable?
It's like XML or
You mean like where does it come from?
What is it? I mean, did you write it out in XML? Did you?
No. It's I get it from the
subclass
theme.
of drawable?
I get it from the theme.
What is it? It's drawable. It has subclasses.
Yeah,
What is it?
depends.
This one that you have.
I suppose I could step in the debugger and see. I mean, the default one in the Hollow theme is probably a shape drawable. No, it's a 9-patch. It's a 9-patch.
Oh, okay. I thought you wrote it.
No, that's what I'm saying. I'm pulling it out of the theme.
I thought you wrote the thing.
Whatever the Hollow theme has for its list divider, that's what I grab. And that's why I'm doing it that way, so that it would draw consistent with any other list. Because that's the same one that ListView would use when it draws its own default dividers.
Okay.
So I could make my own. I can make it any one of those.
Yeah, I thought you had.
Yeah. Yeah. And if there was a custom theme, they could set it to any kind and it wouldn't affect me because I just pull whatever the default drawable is. And all drawables in that case work the same because I just need to size it and draw it. And then however it works is however it works. Okay. Mm-hmm. Good question. Other questions? Okay, let me show you this one last thing. So just to point it out, if you're interested, so this is the URL for showing the stuff on GitHub. It's on my GitHub RecyclerView Playground. The blog post series is on my website. So wiresareobsolete.com. Right now there are 2 parts of the 3 posted. I don't know when I'm going to do the 3rd part soon. But these will go through. First of all, I have some of those references in it. So discussions of like this is a GitHub repo from another Android developer that is specifically dedicated to writing custom item animators. So I didn't really do that here. If you're curious about how those look, the link there is in the blog post. But this blog post series goes into much more detail about all the pieces that went into building that grid layout manager you just saw. Okay, so this talks about, it talks about the example, how the recycler works, the differences between those different types, how to implement on layout children and when it would be called. So this dissects everything you just saw in much more detail. So if you're curious and actually getting in and trying to build one of these things, besides just looking at the sample code, you might be interested to look at the actual details in a little bit more. Well, no, they're not all in here. Just the relevant pieces. I suppose by the time you get through all 3 blog posts, you'll have seen some of the 600 lines in every single one, yes. So, okay. Well, that's all I got. So.